The first one is, I'm going to get into is histidine. A lot of you may not have heard about or understand histidine. It's the next amino acid in terms of after some of the other ones that we've already done a lot of research with over the years that we need to do some understanding of where that requirement is. Then I'm going to follow up with some of the work that has been done on phase feeding. Mariana did some trials last year that showed that we could reduce the number of phases from a 4 or 5 phase down to a 2-phase program in the growth finish period if we formulate to pretty high lysine levels when we do that. The last area I'm going to talk about is then with what do we do with some of these corn levels and corn byproducts that have these really high leucine to lysine ratios. We know that we have lower feed intake and lower average daily gain. And so is there a way that we can get around that and do the ratios for other amino acids increase when we do that? And so first start off with histidine. As I mentioned, histidine is one of those that we've thought of coming down here as the 6th or 7th limiting amino acid. If you look at the NRC, the suggestion is that a histidine needs to be about 34% of lysine. And where this becomes important is when we start adding lysine, threonine, methionine, tryptophan, and valine, which are all being added in nursery diets, in particular on a regular basis now, and valine finding its way out into finishing diets as the economics works out for it. And we've been told by the amino acid companies that we're going to have isoleucine to add pretty darn quickly on a feed grade basis. And so when that becomes available, it really puts the pressure on whether isoleucine is the next limiting one or histidine. With some of our diets, it would suggest that histidine would be more limiting than isoleucine if you follow NRC's recommendation. Therefore, we wanted to look at this level in nursery diets, and want to credit Kevin Tichette and Ajinomoto for supporting this research. And Enrique did a lot of work getting ready for these trials. One thing when you get into histidine and trying to get a requirement study of any sort, you need to make a diet that's deficient in the first place, that you know is going to be deficient. That's hard to do when you're getting down to these amino acids. And so these diets are actually a very high whey protein concentrate diet. And so not a very practical diet from a cost standpoint, but a diet that worked quite well to be able to test the histidine to lysine requirement. And as you can see, as you increase the histidine level of the diet, we get a nice improvement in average daily gain. Up to about a 31% is where the break point came in for histidine to lysine. So a little bit lower than what the NRC was suggesting. And that was driven an awful lot by feed intake, but you see that when you go to the really low levels, you get down to 24%, you see this really drop off in growth rate. With the break point on feed efficiency was a little bit lower than average daily gain or feed intake, running about 29%. And so the take home from this is about 31% histidine to lysine, so it tells us that in most of our diets, isoleucine does come in before you run into a histidine issue. On the phase feeding side, again, this is the quick summary from last year, as Mariana showed us that we could go from a 4-phase program to a 2-phase program and have the same overall performance, the same overall economics. Some of our European colleagues and our Australian colleagues have told us that this is what we were going to see and that we wouldn't have any differences in performance, but of course you have to prove it to yourself. And the one thing that does change that I don't want to belittle on this is your environmental impact. You always have to be concerned about, because when we are formulating above the requirement during some of these stages, you expect to have more nutrient excretion than when you're formulating right along the requirement, like in a 4-phase program. So nitrogen excretion, there are some advantages to adding more phases. But when you're formulating, again, this line in here, the slope of that line is from the PIC, from their recommendations for maximum average daily gain, and so that's a very important point, because as we get into these other trials, we need to understand how does that relate when we're not formulating to maximum, maybe formulating more to minimizing feed costs as an example. And so the first trial that Mariana did to follow up on that is we wanted to prove, could we do it again? And then if we can do it with 2 phases, can you do it with 1 phase? Okay? And so that's basically what this study is the exact same format as the previous study, just looking at 1, 2, 3, or 4-phase programs. And to really jump to the end of this is hot carcass weight. It proved that, again, the 2-phase we could definitely take it all the way down to 2 phases. 1 phase, the problem is that those pigs are so far below their lysine requirement at the beginning of the period with how long we carry pigs in the U.S. to heavy market weights, that you really can't make one diet work over that entire time period. From an economic standpoint, though, it's amazing that the economics comes out that it would argue that you could feed anyone a 1 phase up to a 4 phase and not have a huge change in the income over feed cost in these different programs. And so there are some options. I said the 2 phase program, again, showed that it worked quite well. So we wanted to go back and say, well, not all of our diets are formulating to that high a level. Yeah, that's what some of the companies are recommending, these really high levels for the genetics, and we know that it'll meet their needs for maximum growth rate. But if we formulate a little lower, we know we lower our feed cost per pound of gain. And of course, this time, this kind of situation when we have low market prices, those things become obviously quite critical. And so we ran the same trial. Mariana did this with just lowering all those phases. And so we left the same bar on from the previous slides, so it's the same slope, but you see that the phases all drop down. And so that last phase in every one of these, and this is, I think, a very important point, is below the requirement for maximum growth performance at the end. And some of these responses may change a little bit if we would have that last diet a little bit higher on lysine levels. But we looked at this again, 1 through 4 phases, and we get a lot different response than what we see when we had those lysine levels higher. First off, you can see in the first phase how much impact that lysine level had. Again, we knew that the requirement for feed cost per pound of gain was at 107. The requirement for maximum growth in this phase is actually a little over 115 or 118 in that stage. So we see the fall off in growth rate when we do the 1 phase or the 2 phase. What we've seen in the previous trials, we see some of that coming up here. Once we put those on a higher lysine level, they get some compensatory growth and grow pretty well in that 2nd phase. And again, we still have the lower lysine level on the 1 phase, and so they're lagging behind. But now that when those pigs are closer to what their ideal lysine level was for that phase, whether they're on the 4 phase or the single phase, no differences in performance during that period. But then at the end, again, we're seeing compensatory growth. That single phase at 0.79 SID lysine all the way through had some compensatory growth in that last phase as those pigs went to market to make up for some of their lost performance. However, when you look at the overall performance and average daily gain, we see that single phase, again, fell off quite a bit on average daily gain as compared to doing 2 phase, 3 phase, with the highest average daily gain with the pigs that were on a 4 phase program. And feed efficiency, we see the same kind of thing. As feed efficiency was the best with the 4 phase, being just slightly under those requirements of those pigs all the way through, as compared to doing a single phase, you had much higher feed efficiency. And so you look at the hide carcass weight, follows the average daily gain obviously quite closely, with hide carcass weight improving as we go to more dietary phases, moving from that single to a 4 phase. And the income over feed cost, here you can see again the income over feed cost now is much higher for the 4 phase program as compared to the single phase, with the 2 and 3 phases being intermediate and again much lower numerically than what the 4 phase diet is. So the summary of this is that if you formulate to higher lysine levels, you can reduce the number of phases. Okay? But if you formulate to a little bit lower lysine levels, again closer to what we think that the requirement is for feed cost per pound of gain, being slightly under their requirements for maximum performance, then 2 phases is not equal to 4 phases in the program. So there are some flexibilities, some different ways that people can attack this in terms of feeding the pigs, but generally, most of the time we're going to be in a 4 or 5 phase program from wean to market, but there certainly isn't a need, and we've never found any evidence to go in any more phases than that in any of these trials. Then I want to finish up with a little bit of discussion about this branched chain amino acid issue. Branched chain amino acids are valine, isoleucine, and leucine. Those amino acids are very high in corn products. And so anytime we have in these ingredients that we have a lot of protein coming in from corn, it's a concern of whether the high levels of those amino acids cause us trouble. This is just a recent experiment that Enrique did with high protein DDGs. We're going to see more of these DDGs come onto the market. These happen to come out of the Phillipsburg plant here in Kansas. They've got about 9 plants, I think, now in the country, I think, Bob, that they're making high-protein DDGs. The ICM has put the equipment in. These are actually a pretty nice protein source. The problem is it's a corn protein, so we want to look at what impact it has when we add increasing levels. Here we see this reduction in average daily gain in this late nursery phase as we go above that 10% of that high protein DDGs. And it was driven mostly by a reduction in feed intake. Okay? The energy level of these DDGs is actually pretty decent. It's a decent oil level, and they've removed most of the fiber out of this product. And so it's got a pretty good energy value. So when we look at the feed efficiency holds pretty well across all the way up to 40% in the diet. And that's really was the goal of this experiment, was to determine an energy level. And Enrique found that the energy level of this particular high-protein DDGs was about 97% of the energy value of corn. So pretty reasonable energy value. The trouble is you got that linear reduction in average daily gain in feed intake, and the question is why? So Enrique, for his prelims, has worked on a meta-analysis, and appreciate CJ and Keith Hayden for having some leadership and helping us support this meta-analysis and pulling this data together. So he pulled all the different experiments that have been done with different corn products or different synthetic amino acids, looking at diets that have pretty high leucine levels or a range of leucine levels. And what his data is telling us is a few very important things. One is the isoleucine to lysine ratio is important, which didn't surprise us too much. But the branch chain amino acid relationship to each other, the isoleucine and valine relationship to leucine, all of these are higher in corn products, but leucine goes up much faster than what valine and isoleucine do. And so you have to be careful having enough isoleucine and valine when we have high leucine levels. Then also the isoleucine to tryptophan ratio came in. And why that's important is we thought that there may be something going on between the branched chain amino acids and tryptophan, and whether the other ones are important to his modeling showed us that only isoleucine came in, but these compete to get into the brain. All these, they have the same transporter going across into the brain, and so if you have too high a level of branched chain amino acids, they may reduce the amount of tryptophan that can get into the brain, and that may have an impact on driving the feed intake reduction that we're seeing. And that's what his modeling is showing us. And when you account for those things, using his prediction equation, the predicted average daily gain versus the actual average daily gain on all those various experiments, his model is saying he predicts it pretty darn well. And so our next step is to take this out and validate, can we take these diets that have very high leucine, add back tryptophan and valine and some isoleucine, bring them back so that we reach those ratios. And it's not extreme changes in some of these ratios, but it's moving from some of the lower levels that we found in some of those previous years to bringing them maybe closer to what some of the Europeans argue some of those ratios really requirements are. And it looks like the modeling is telling us that that may be some of the reasons that we get differences between our recommendations and some of those in other areas in the world. Okay. Last thing I wanted to just finish up with was one slide. We want to make sure we talked a little bit about mycotoxins today. And particularly for our Kansas producers, we need to do some testing. We need to make sure that we know what you've got in your corn. We have had, particularly as we go west of Manhattan, the central part of the state, some really bad fumonisin situations. I've got up here a couple different samples that were tested out of an area. I couldn't believe them at first when I saw them. 700 parts per million, 500 parts per million of fumonisin is extreme levels. I mean, the highest level I'd ever seen anywhere on fumonisin was in its grain screenings. I'd seen about 130 ppm, and that was I'd never seen anything over about 15 before that. And so these are extreme levels, but it's not too surprising. And the veterinarians in the world that have dealt with and the Kansas that have dealt with this problem know that it's pretty detrimental. Killed a lot of pigs with that kind of level, and there's been some horses that died of that. So anybody that has a horse problem and wants to get rid of a few, you probably could maybe a way. But in all seriousness, you need to be careful with corn in Kansas this year. If you have some low bushel weight corn, you want to be really be careful and have it tested. The desired fumonisin levels, we certainly want to be under 10 parts per million, and there's concern between 5 and 10. The reality is there's very little data on knowing exactly what level of fumonisin is safe in pigs, because we haven't had that much corn that's at that extreme high levels. If you are concerned, consider cleaning your corn. Removing the dust from the corn removes a lot of the fumonisin. We showed some of that data last year. That helps quite a bit, and make sure you're doing, again, testing. The toxicologist, Dr. Steve Ensley, has put out in several of our popular press some of the kind of warn people, make sure that you're doing some testing if you haven't done it. All right?